Good morning, good evening, good afternoon, boys and girls. So, before we start with the lab, there's something important that you should be aware of. In real life, when you are a network engineer and you work with networking equipment for different companies, public companies or private companies, the scenarios that we have seen along these lessons during this course, they could happen. They could be easier or they could be more difficult. They could be the same at an intermediate level. So just for you to have an understanding and be aware of that. Now, today we're going to go over VPN lab, VPN site-to-site IPsec, and we will have this addressing table. Let me just increase the size for a moment. Pretty much everything is pre-configured. Let's see. We will be adding the license to the security technology package, enabling this in the router. Then we will work along with access list, crypto ISA KMP policy, IKE phase 2, IPsec, then crypto map, and so on. We will move along and move to router 3 to configure access list, also the crypto key, in order to have that tunnel connection from a site to another site, the best possible manner. Some protocols that you can see, for example, transfer set, you have the policy for phase 2 for IPsec and the crypto map. And then we have to apply that specific uh, map to an interface, serial 001. And that's pretty much the lab for today. We are going to go step by step. I will show you along the way how to complete this lab. So let's go, let's go. Let's start working along and add the correct configurations to router 1. Blah. All right, so the tunnel will be configured between router 1 and router 3. That will be the IPsec VPN tunnel that we will work today. So what's the first thing we have to do? Enable the security package in router 1. So let's go ahead and copy this specific command. Let's go to router 1 to enable the security option. Hopefully it should work with no trouble, with no problems. Now I'm wondering if there is a password for this because he's asking me for a password. So let's validate, and it looks like we have to go with this one for the access to the device. So let's paste it there. We have the console password. Let's see. Let's see if what is going on here. SSH. Why are we not able to access the device? Maybe we need to access it via console. Hmm. We'll figure it out. I'm going to pause the video to investigate that, and I'll let you know what I do to fix this. Mm, console line. Enable password. Hmm. Enable password. Hmm. Huh. Quite strange. Let's see if connecting an SSH cable telnet for access to router 1 will allow us to access the device. Yeah, the password Cisco MPass 55. This is so strange. Console. Huh. Let's see if maybe we need to reset the lab or something. Hmm. Router 1, but we are not able to access router 1. What the fuck? Cisco. Unauthorized access. There's something strange here. Config T. Please unlock the content. This is so weird. So weird. The packet tracer lab is not available. Show version. Voy a probar con todas las claves a ver cuál de estas es. Reconfigure. Okay. The console. The console and then the enable. The enable. We have to do the console and then the enable. Okay, okay. So, okay. Okay. I think I got it. I think I got it. So let's go to router 1 and first let's do a Ctrl Shift 6. First, we have to add the console option. So if we go here, we will get this prompt. And the first thing we have to do is copy this one, the line console password. That's the first one we paste there. And once we are there, we have to do enable to access the privilege option. Let me just copy this there. And we should be able to configure stuff now. Perfect. So that's what we need to do. First, we use the line console password, and then we use the enable password. Since these two routers have been pre-configured, we have to be aware about this. So let's go with the license we were trying to do before. And let me just go ahead and paste it there. Let me paste it there and let's choose yes. And that's pretty much everything. Now, accept the terms and conditions, save the configuration, and reload the router. Do you guys remember how to do the saving? Copy, dash running, dash, and then startup, dash config. Now, I'm having some issues there. Let me see. Copy, running, config, startup, config. There you go. So it's actually copy, running, dash config, startup, dash config. What I doing something incorrect there? It was startup config. Oh, it was running config, not copy running. That was my mistake. So you see, those small details are important when you're working in production environments as well. Reload. Let's do the reload. We have to reload this device. And it will take a few seconds. All right, so we are in the router now. The configuration should be the same pretty much. So let's copy the console password first, remember? And then let's use the enable password. Let me just copy that one. It's very similar, but it has a little bit of differences. We do enable, then we paste that password, or we can just type it out. Okay, what else? An access list. We have to allow some traffic. So let me just add this configuration and I will explain later why do we need this access list here. Let's do a config T and let's paste it there. So is a permit IP 192.168.1.0 is allowing a specific host and another mask there. Is the wildcard mask of /24, which is 255.255.255.0. So this is what we're doing right now. Configure an ACL 110 to identify the traffic from the LAN on router 1 to the LAN on router 3 as interesting. This interesting traffic will trigger the IPsec VPN to be implemented when there is traffic between R1 and R2, R3 LANs. All other traffic source from LANs will not be encrypted because of the implicit deny all. There is no need to configure a deny IP any statement. So how do we add this configuration in a quick manner to the device? Let's just copy this. Let's go. Let me go ahead and close this. It's from a previous lab that I was working along with a student. And we need to do the following. We need to clear these options. What are we going to do there? I will explain it in a minute. First, let's add the configuration and then I will explain what are we doing exactly here. Let's add the configuration to the router 1. And now let's go ahead and explain it a little bit better. So in this step, we are going to configure the crypto ISAC KMP policy 10 properties on router 1 along with the shared crypto key VPN PA55. We are working with the phase 1 table. These parameters will be configured for, therefore, only the encryption method, key exchange method, and DH method will be configured. The default values do not have to be configured. The highest DH group currently supported by Packet Tracer is group 5 in a production network. You could configure at least DH14. So maybe Packet Tracer has less capacity, but if you're working with production environment, you will have until DH14. So crypto, ISAC KMP, policy 10, encryption AS 256, authentication pre-share group 5, exit, crypto ISAC KMP. And then we have the key VPN PA55. Nowadays, if we can configure something higher than 256 is actually recommended because remember this lab is from 2017, so security has moved a long way and technology. We are already in 2026. So if you have a better option than, for example, 256, something like 512, that would be my recommendation for the encryption. Okay, let's go ahead and configure this crypto IPsec transfer set option. Let's add that to the router. Moving along the same pattern. And now we are adding those specific protocols and encryption protocols per se. What else are we missing? We have to configure a map. Create a crypto map, VPN map that binds all of the phase 2 parameters together. Use the sequence number of 10. So let's go ahead and copy this and the same option. We go to a notepad, we copy and paste it there. We clear this part, this section, and we're going to remove this that is not required for the configuration. It might take a little bit, but be patient. Let's copy this and let's go to the router. Now, what are we doing and what have we just configured? Appear a transfer set, the description for the VPN connection that goes from router 1 to router 3, a match address to match the ACL that we configured previously. And now all is missing is to apply that map. So let's go to the interface of the router. Let's go to the interface of that specific router. I'm going to stop sharing the video for a moment. And you will do the following. You will do the following. Okay. Interface, serial 000, and crypto. Crypto, map, VPN dash map, enter. Are we missing something? Where are we getting this error? Yes, the P, of course. We are missing the P, the letter P. That was the problem. As you can see, it's not case sensitive. It was a capital P, and it worked effectively with no issues. Now we have to do the same, pretty much the same configuration on router 3. So let's go ahead and work on that. Let's see the percentage completed for this lab. So far, we got 50%, meaning that the configuration has been successfully completed. We do a do WR or a copy running config startup config. And what are we missing? What are we missing? Okay, let's go to router 3 so we can work our way there. First thing we do, remember, boys and girls, what do we do to access the router? Let's go to the specific password that we have for the console line, and let's go ahead and copy this. Paste this there. Amazing, great job. So enable, let's go ahead and add that enable password to the router. And now config T. Next thing we do, okay, we have to add the license. Hopefully it's the same process. Do we need to do it? It doesn't look like it's asking for that, but let's see if we can do it. Let's see if we can do the same process. Let's go ahead and copy this just to cover our back. And let's configure this in router 3, just in case, Maybe the module is already with this configuration, but we just want to cover our backs. Let's do a do WR. Let's do a do reboot, and that's it. Let's go ahead, Ctrl+Shift+6, and do you know what was the error? It wasn't do reboot. What was the correct command, guys? Config T. Do reload. That was the correct command. I was doing a mistake there. It wasn't reboot, it was reload. So we click yes here, and we are doing a reboot of our router. Remember, we're working along with this router 3 device. Okay, perfect. So it shouldn't be difficult. Let's just go ahead and copy this password there so we can have access. We can close the router 1 so it doesn't get confused. And now we need the enable password. So let's go ahead and copy and paste it there. Remember, enable. It's very important that you type that and then you type the password. Now, what do we do on router 3 before we start adding these access lists, which is also called 110? We have to do the following. Config T, and it's actually an extended access list as far as I see it. So let me just copy and paste it there. And this is what we're doing. We're replicating or duplicating the same configuration from router 1 in router 3, but backwards. Instead of allowing access to the 182 and 168, the 1.0, first we allowed access to 182 and 168 that 3.0 and then to 192 and 168 that 1.0. Let's see the difference. Before, The 1.0 was first and the 3.0 was second in the access list. Now, in option to permit this IP, we have to enable the access to the 192 and 168.3.0 first and 192 and 168.1.0 second in this specific order. Let's see if we did it. Yeah. Do show access list, access that list, and you can see it has been successfully configured there. Now, do you guys remember what was the easiest way to add this configuration to the device? Just copy and paste this, remove the options that we don't need. Okay, we are adding encryption, we are adding authentication, we are assigning a specific group, assigning the crypto key. That's pretty much the process. Let me just copy and paste this in the router 3 device. Great. Now, this one, 10.1.1.2. Where is that one? We configured that one before as well, router 1. Where do we see that one? 10.1.1.2 is actually in router 3. And then the 2.2.2 is actually in router 1, but somehow we are just configuring in router 1 10.2.2.2. Okay, that was the specific one. And then the 1.1.2, I think that's the second one we are configuring now. Let's validate that. Let's go to router 3 here. Yeah, that's actually, that is the, what is the name of that one? The peer IP address. We are configuring the peer IP address in each of the devices. So pretty much that's what we're doing. Let's see. If you take a look at the IP address of 10.1.1.2 is the serial interface for router 1, and 10.2.2.1 is the serial interface for router, actually 10.2.2.2 is the serial interface for router 3. So that's basically the peers that we are configuring right now. Now we want to communicate from router 3 to router 1, and that's the reason because we started with this configuration. Okay, let me copy and paste this. Have we done this yet? Yeah, that's pretty much done. So let me just add that protocol, the protocols. Let me copy and paste this. There you go. Amazing job. Now I have to copy the map, the crypto map. We configured the ISAC KMP, and now we have to configure the crypto map. So we're getting there. We're getting there. We're almost there. Be patient. Okay, let me just copy and paste this configuration. Let me enable the camera for a moment. And let's continue moving forward. Let's copy and paste this. Let's go to the device. And voila. The new crypto cap. The new crypto map will remain disabled until a peer and a valid access list has been configured. Now, that is basically notifying that we have to enable in the interface the map. That's something that we will do in a moment. So we go there, we have to do interface serial 001 crypto map VPN Dutch map. What are we missing there? That's pretty much everything. Enter. And there you go. Let's do a do WR to save the configuration, Ctrl Shift 6 if you get this error. And there you are. Now we have to validate that we have configured everything successfully for this. So we have to execute the show crypto IPsec SA command on router 1. Let's do that. Let's close this for a moment. Let's go to router 1. In fact, you can see that this is to 100%. We have successfully configured the lab, but we want to run the extra mile and do a do and then paste this command. And there you go. Amazing. Great job. Now you see the interface, the crypto map, the BRF. In this case, we don't have any. The peers, the encapsulation, and the protocols that are running there. That's pretty much everything that we configure for this VPN tunnel. Okay, now we have to do a connectivity test from a computer. Let's see if we can do the packages here. Are we able to ping? Yeah, it takes some time because of the conversions, but we are able to ping the device. How do we do it the other way? Let's say if I want to use the command prompt, how do I ping from PCA to PC3? So we send a ping to 192.168.3.3. Is that what we want? Let's validate. Yeah, that's what we want. And we can do it the other way. We can go to PCC. We can go to the command prompt. We can send a ping to the 192.168.1.3. Amazing. What else do we need to do here? We already execute the crypto IPsec SA. That's pretty much everything. We can run the same command on both routers. Let's go to router 3 and let's run this command as well. Let's do an end. Let's paste it there. And there you go. The crypto, the encapsulation, the tunnel, everything is active and successfully configured. Now, what have we done in this lab? Basically, let me just share with you. We created an IPsec VPN tunnel between router 1 and router 3, which is basically doing an encryption and protecting the data and the communication between R1 and R3. That's basically what we have been working on today, creating the IPsec VPN tunnel. Let me change the color to red. Let me clear the drawings. So this router is communicating with the IPsec VPN tunnel, and there are some encapsulation protocols and some communication that is encrypting the data, the specific data. That's what we have done today with this lab. Now, how do I go ahead and reset the lab? It's pretty much easy. I go to reset activity, I'm clicking OK, and that's everything. Let me save this, and you can start from 0. You can see the 0 there of the completion. That's pretty much everything that we have covered today. So let's go ahead and review a little bit of some of the topics that we have covered today for this lab. So basically, we added the phase 1 and the phase 2 parameters. We added the encryption methods and the encapsulation methods to have the security in our router devices. Let's go ahead and check the background scenario that we have to check from the beginning, but maybe we didn't go into it too deeply. So in this network topology, it shows 3 routers. Your task is to configure R1 and R3 to support a side-to-side IPsec VPN when traffic flows between their respective LANs. IPsec VPN tunnel is R1 and R3 via R2. R2 acts as a pass-through and has no knowledge of the VPN. IPsec provides secure transmission of sensitive information over unprotected networks, such as the internet. IPsec operates at the network layer and protects and authenticates IP packets between participating IPsec devices, peers, such as Cisco routers. So remember to complete this lab by yourself. Take the time that you need. Practice makes perfect. So you can become a Cisco network engineer expert in this field. Take care, boys and girls. It's been a pleasure working with you today, going over this lab and practicing some commands, trying to understand the connectivity between one side and another. Remember the encapsulation that we have configured today. It was mainly related to, where was it? Let's validate that for a moment. Okay, we have configured the encryption. We configured the encryption algorithm, the encryption ESP option parameter, the peer IP address, the access list, the crypto map, the SA establishment was successfully completed. And that's pretty much everything we gone over today with this lab. Take care, boys and girls. It's been a pleasure. Until next time, my name is Cesar. Take care.